What's up guys, it's me Sir Ernest, and today we're going to solve problem 2.19 of Fowles and Cassiday 7th edition. The problem reads, a surface-going projectile is launched horizontally on the ocean from a stationary warship with an initial speed of v0. Assume that its propulsion system has failed and it's slowed down by a retarding force given by F is equal to negative a e to alpha v. So letter A, find its speed as a function of time, and find letter B, the time elapsed, and letter C, the distance traveled when the projectile finally comes to a rest. Here we take note that A and alpha are positive constants. Okay, so since the only force acting on the object as it slows down is this force, so therefore the equation of motion becomes F as a function of speed will now be equal to negative a e to the alpha v, and is equal to m times derivative of v with respect to time. Now we can solve this by solving the integration. Okay, so to integrate, we now have the dv over e to the alpha v, and this is equal to negative a over m dt. And then we integrate. The time equal to 0, the speed is v0. The later time t, the speed is v. Solving this, we now have e negative 1 over alpha e to the negative alpha v evaluated from v0 to v, and is equal to negative a over m t. Okay, so if we're going to solve this, this will now be equal to e to the negative alpha minus e to the negative alpha. So this is v and v0, and this is now equal to alpha a over m t. Okay, and then you can just solve the algebra after several steps. The velocity function, function of time, should be equal to v0 minus 1 over alpha times the natural logarithm of 1 plus alpha a over m e to the alpha v0 t. This is now the velocity as a function of time. Now to solve for the elapsed time, okay, so that means we set another boundary condition wherein at that elapsed time t, the speed is 0 because it comes to a rest. Okay, so substituting this to our velocity function, this becomes 0 equals v0 minus 1 over alpha ln times 1 plus alpha a over m e to the alpha v0 t. Okay, and then we can just solve the time t, and we'll end up with this expression. Again, all the algebraic, so intermediate mathematical manipulation is just simple algebra, and you can do this at home. Okay, but the important thing is that the end result, the time elapsed, will now be equal to m over alpha a times 1 minus e to the negative alpha v0. Okay, so you will notice that the function, the time, would be related to the initial velocity. Okay, and then lastly, letter C, the distance traveled will just be a will just solve the position function x. Okay, so we all know that this term will just be equal to v dv dx by chain rule. Okay, so now we're going to solve this together with this. Okay, so therefore we can rewrite this equation as the equation of motion as e to the alpha v e to the negative alpha v, just transfer in the other side, times v times dv, and then m and dx will be transferred to the other side, which gives us negative a over m dx. Okay, and then we just do the simple integration. Okay, again, we're not going to solve this in a more detailed manner, but I will just tell you that this can be solved. You will notice that this can be solved by integrating by parts. Okay, so the end result here is that position function will now be equal to m over a alpha squared times 1 minus alpha v naught e to the negative alpha v naught. Okay, so the integration limits would be as follows. So at the initial position 0, the velocity as is v naught, and then at a later time x, the velocity is 0 because we're looking at the distance to rest. So that would be our integration limits, and then by so doing this, you'll end up with this equation. Okay, so that's it. And that is problem 2.29 of Fowles and Cassiday 7th edition. I hope you learned something today, and thank you for watching, and I'll see you guys in the next video. Bye bye.